For today, we're going to look at basic properties of logs. How these were designed was looking at properties of exponents, such as we know a to the 0 power, or anything to the 0 power is 1. Well, what we saw yesterday is, why don't I convert this, or use my conversion to make it into a log? Well, doing so, you get that log base a of 1 equals 0. So if you see a log, and this number right here happens to be a 1, then that means that log, no matter what the base is going to be equal to 0. Likewise, here, if I have log base a of a, so that these numbers are paired up, and they're equal, then that log will always equal to 1. Now that's kind of the same as what this property is saying right here. So notice, if you have your log base and your log value there that are the same, then that log will equal this exponent. Well, if this exponent's 1, then of course it's going to equal 1, based on this property right here. So essentially these two are about the same. If I were to take this and turn it into an exponent here, my base a to the power of x equals a to the power of x. Well, that makes sense looking at it this way. So as you can see here, you're really not expected to memorize these properties, because all you can really do is just turn them into exponents, and it can clearly see, yeah, that makes sense. A to the power of 1 equals a. This one down here is just kind of a fancy one. Normally don't see a exponent expression with the log as its exponent, but if you do, and they happen to have the same base, so my exponent base a is the same as my log in that power base a, then the value of that log, x, is equal to the total value of the expression, x. So with these two right here, you're looking for pairs. If these two are paired up and equal, then these two are paired up and equal. So let's look at a couple of examples. Looking at the first one. If my log is 1, right here, not worried about the base. If it's 1, then it equals to 0. So let's solve this equation based on this property. Log base 7 of x equals 0. What will be the value for x? Note what's missing. I know that my log is 0. Therefore, this value right here has to equal to 1. That is correct. Now, like I had mentioned, everything I showed you today, you don't have to memorize. Why don't we just use our technique from yesterday and turn this into an exponent? So log base 7 of x equals 0. What is the base of my exponent going to be? 7. What's the power? 0. So 7 to the power of 0 equals x. And what is anything to the power of 0? 1. So
you're right.
X equals 1. Oops. So x equals 1. So you'll see with these logs and exponents, there are multiple ways to solve the problem. This is one way, using a basic property, knowing that this is equal to 0, so that has to be 1. Or you can convert it to an exponent and clearly solve it that way. Let me have you use that same property and solve these two equations. Log base square root of 4 of x equals 0, and log base 9 of 1 equals x. Solve for x. Give you a few seconds.
2 seconds?
Few seconds. 2 seconds? You want 2 seconds? We'll do 2 seconds. All right, let's go.
Oh my gosh, man.
You should be able to, right? If you're using this expression, log base square root of 4 of x equals 0. Well, my log is equal to 0, so what's x? 1.
Uno.
And here, log base 9 of 1 equals 0. Again, you recognize that that is a 1, therefore your log has to equal 0. If you didn't see that property here, well then you can just plug this in your calculator and it'll give you the value of 0. Or you can convert it into an exponent. 9 to the power of x equals 1. That power has to be a 0 for it to equal 1. Next, let's look at another property. Log base a of a. So I'm looking to see if these are paired up in the same number. If that's the case, then my log will equal to 1. So solve this equation. Log base 2 of x equals 1. The only way your log is going to ever equal to 1 is if these are the same number. So what does x equal here?
1.
base 2 of 1 equals 1?
Oh, no.
Zero.
Log base 2 of 0 equals 1?
God, I don't know.
These have to be, look,
A.
log base A of A, so these are the same number, then your log's gonna equal to 1. It equals to 1, so these have to be what?
Two.
Very good. These have to be the
Ah.
same number,
That's two.
so x equals 2. X equals 2. Now, seemed like you were struggling with that. That's fine. What if you didn't use this property, you use conversion? So let me convert log base 2 of x equal to 1 as an exponent. What's the base of my exponent? 2. What's the power?
One.
1 equals x. Well, there you go. You can clearly see that x equals 2. Next, let me have you solve, using that same property, these two equations.
Where'd you get that?
Temperature.
And one. That's for like half a gallon or just the stuff?
The stuff, the extra stuff I bought with Captain
Then you
Gown.
can't.
If you just bought the Captain Gown, they're gonna get you like on.
It's on the seventh. It's on the seventh. They give us a count.
No, I got the
second.
cap and gallon and the extra stuff.
Already?
They said on another event, which will be the seventh, because
I didn't focus.
It's easy, you don't even need a calculator.
I know, I just
You
wanna-
don't? No.
I just wanna focus.
All right, what's the first one? Log base x of 1/2 equals 1. I notice my log equals 1, so then x must equal 1/2. Very good.
Smart over here.
Next, log base e of 3
Got this one.
to the e of 3 equals
Oh.
x.
This one.
These two are paired up in the same value, which means x equals what? What does x equal when these two are the same?
One.
1. Yep, based on our rule, a equals a, then x is 1.
I was like, okay.
Using that same property, but instead of a 1 here, I'm calling the exponent x. So if, again, these are the same value, then that means these are the same value.
Eggs.
Okay.
So, log base 4 of 4 to the x power equals 9.
X equals 9.
I notice that these happen to be the same, which means these values have to be the same. So x equals what?
9.
X equals 9. And keeping from the tradition, let's go ahead and convert this into an exponent and see what it looks like.
Yes, sir.
So what's the base of my exponent?
4.
4. What's the power?
9.
9 equals 4 to the x.
To the X. I was about to say 4.
When we solved exponents, we saw something similar to this. When they have the same base,
You-
we then just look at the exponents. And I see with my exponents, 9 equals x, or x equals 9.
On purpose?
Yeah.
You're lame.
Now, let's use that same property, solve these equations. Log base x of 2 to the 12th power equals 12, and log base 5 of 5 to the square root of 3 equals x. I'll give you a couple of seconds.
Easy stuff.
I hope so. So let's see.
Watch me fuck this.
Note, these are the same value right here. So 2 has to also equal what?
2.
Where?
Oh, no. Oh, you see what it's?
This value right here. So x equals
2.
2.
You could have continued.
Next, these are the same. Therefore, what two have to be the same?
The X. and
The x and the
X1.
exponent. Yeah. So x equals
Square root of 3.
square root of 3. So they get paired up. If these are paired up, then these are paired up. Our last basic property, I have an exponent, and it's being raised to a log. And then exponent's base happens to be the same base as my log. So this a is equal to the base a of my log, which means your log value here will equal the solution, x value there. So when these get paired up, these get paired up. So look at this equation. 3 to the power of log base 3 of x equals 7. Do my exponent and log have the same base?
Yes.
Yes.
They do indeed. Which means this number has this x value has the same value as what? 7. Very good. So x equals 7. So use that property to solve these two problems. X to the power of log base 9 of 5 equals 5. 3/2 to the power of log of 3/2 to the square root of 7 equals x. And once again, find off a few seconds to think amongst yourself. So the first one. What does log have to equal? What does x have to equal to make this expression true? X has to equal what?
5. 9.
I hear two numbers. There are two numbers in
Oh,
here.
9.
Somebody's right.
9.
9.
No.
Sorry.
That is correct. If this log equals that expression there, then that means this base has to equal that base. So x is equals 9. Next, I have this entire expression. It is equal to x. Sure, you could probably just plug this all into your calculator, but it's much easier to use the basic properties and say that x equals what?
Square root of 7.
Square root of 7. That is correct. X equals square root of 7. Because I noticed that my base are the equal, which means these two have to be equal.